Welcome, I'm Carl Tape. We'll be looking at animations of plate tectonics. At this early stage in the course, you're only asked to keep an open mind when watching these animations. We have not yet discussed the evidence used to understand current, past, or future plate tectonic motions. And here we're only looking at the surface of the Earth. We have to keep an even more open mind to imagine what's going on deep below the surface of the Earth. And here's what I mean by an open mind. If you're not used to thinking about the world like this may be kind of a shocking view. We are familiar with things like dinosaurs in the past. And when there were dinosaurs, the Earth looked very, very different. And this shows the white outlines show the current configuration of the continent, and the ancient land masses are shown here in green. We can see at this time, this Pangaea, the supercontinent at 237 million years is formed. Really, the planet looks nothing like what it does now. And I want to emphasize that this looks kind of like a cartoon, but there's a lot of geological information and geophysical ideas that go into making these reconstructions. And we'll be looking at what the evidence is for these. So we'll start a video here. I'm going to play from 200 million years. I'm going to speed it up. It goes a little faster here. This is showing the time in the upper left, 190 million years. And we see roughly South America, Africa, North America. These things in here are going to slam in to help make Alaska way up here. You can't even see Alaska. But we see here now North America pulling away from Africa and Eurasia up here. And as you see this piece flying to the north into Alaska, you see the opening of the Atlantic Ocean. Meanwhile, Africa and South America are still hugging each other at 120 million years ago. This will be India shown here, headed for a train wreck with Eurasia. Here we see finally Africa and South America separating from each other. So really intriguing look, speeding up 200 million years of time to reach down to present day, which would be at 0 here. And we can watch the most dramatic action here would be India as it slams into Asia, forming the highest mountain range in the world, the Himalayan. Here we see Australia, some activity out here in the Western Pacific, and more Eurasia, Africa, pulling away from North America and South America. So I encourage you to dig into these videos. This shows the Ice Age, and finally to where we are today. So the following are just links toward a really cool paper from 2020, Scotese and Vanderpoom, available on YouTube. And they cut out sort of pieces to illustrate certain concepts. And I'm really just going to show what they are. You can explore these on your own time, and really after we have a better understanding of some of these fundamentals. So here we go. The first one they showed was continental rifting, and I'm not going to play these. I'll look at one on the India collision just to watch that in detail. But this looks at Red Sea spreading between the Africa plate and the Arabia plate, down here where there's rift and continental rifting happening right down Eastern Africa. They also provide in the publication kind of pictures to augment these animations, which tend to have a lot of detail and maybe more complexity than you need to understand certain concepts like rifting. And so they provide, here's a picture looking at the Red Sea rift here, and then extending onto land, continental rifting. So continents by rift, meaning pull apart. This can happen both in the ocean and within continents. Continental breakup. We just kind of saw that. This zooms in on the breakup of Pangaea starting at 200 million years ago, and how South America and Africa separated. This shows the concept they're illustrating of how during this process you get this kind of stair-stepping type motion of these strike slip faults and spreading separated by 90-degree steps here. And they're trying to show here how basically you get what are called seafloor stripes. And while you have active strike slip motion between these two active spreading centers. Hotspots and hotspot tracks. We'll get into this quite a bit shortly, just to show a picture of the hotspot locations in the present day. These are sites of volcanism, and they're special sites of volcanism because they appear to have these tracks pointing in the direction of older volcanoes. And we'll see how these give us very strong evidence that the plates are moving on Earth. Volcanic arcs on the fourth topic, looking at the Western Pacific. This is Japan, and how certain arcs of volcanoes form out in the ocean. This shows the Aleutian Trench on the far western Alaska, Bering Sea, and on the west of the Pacific, you have these trenches, deep trenches, Mariana Trench, Kermadec, Tonga, north of New Zealand, and going to the west forms these subduction zones, and behind them, volcanic arcs. All along here, the Aleutians are volcanic arcs. Continental collision. We'll play this one just because I think it's a more relatively simpler concept to watch it, but we can also, it leaves less to the imagination to be able to watch this. So I'm going to jump ahead at 2 times the speed here and jump ahead to minute 14. And this is going kind of back in time. Here we are at 100 million years ago, and this will speed up to today. This shows Africa, again, the ancient land masses, and then the current ones shown here, 72, 70. This is India, where it was in the past at 60 million years ago. Here we can see this collision starting at about 40 million years ago, and the Himalayas forming in here. Not surprisingly, when a continent collides into another continent and there's really not easy to go anywhere, you form these very high mountains. And we have these also, the Wrangell St. Elias Mountains in Alaska as well. And so this shows sort of a snapshot today of the consequence of India crashing into Asia. There are these belts of different age and different kinds of rocks. This remains an extremely active tectonic setting, meaning lots of large earthquakes and spectacular topography and landscapes as a result of these tectonics. Terrane accretion, I'm not going to play this one, but just to say from this shot, Anchorage is somewhere in here. This is a chunk of southwestern Alaska, the Alaska Peninsula, the Panhandle down here in the southeast. And this is a chunk of material that collided to help form Alaska. Alaska has a very complicated tectonic history, and this terrane accretion is about pieces coming from far away and glomming onto the North America continent. That's kind of the main theme of how Alaska was formed. And this shows the map of from their paper showing this. This is Canada, US, lower 48 down here, Alaska, Yukon here, and all these pieces are geological features that many of them originated from far away and were accreted or stuck to the continent. So Alaska is not really part of the core North American component. A lot of the Western US was formed through these kind of more exotic processes. The Wilson cycle is about how continental crust and material is made and formed in kind of a cycle. And the image that they provide, this is way ahead of ourselves, but just sort of introducing what we're looking at, view of a continent here of crust and mantle in the earth. Could be something like, say, 30 kilometers thick here with some of the mantle. And the processes may start pulling apart and thinning part of this material. And eventually there can be an upwelling or an ocean ridge forms, and this process continues pulling apart. And then you see here on one side, eventually you can have subduction forming where part of the crust goes down on one side. And as that process continues, you eventually have subduction. This could be, say, India into North America, colliding to form a continent-continent collision, starting over again at the top. So this is known as this Wilson cycle. The formation of Pangea will move forward. Plate velocities is something we'll talk about a lot. A velocity is really a speed with a direction. So you can think of these as speeds if you want to. In this particular animation, there's a reference frame, which is fixed Africa. And this is different from what we will be adopting later. And finally, the authors put together what the future is going to look like if we sort of take our best guess as to where things are headed. Where will things look like millions of years from now? So this is somewhat more speculative, but curiosity driven, thinking about where the Earth is headed. Takeaway topics: plate tectonic reconstructions convey the Earth's plate tectonic configurations going back in time millions of years. These reconstructions are based on geological data derived from rocks on Earth, including the age of rocks and the frozen magnetic field they preserve from the time the rocks were formed.